of science and how they fit together. Earth science deals with Earth and space, things like planets, stars, and rocks. Earth science studies non-living things and their history. Physical science is all about matter and energy, the most basic building blocks of the universe. It includes physics, energy interacting with matter, and chemistry, matter and how it transforms. Life science, or biology, is the study of all living things, like plants, animals, and even single-cell organisms. Science is like thinking about the universe as a Lego world. 1. Physics studies a single Lego and all of its properties, like how it moves around and its energy. 2. Chemistry studies how Legos fit together to create larger things. 3. Life science studies all of the possible living things made out of Legos. 4. Earth science studies all the non-living things in the Lego world. Scientific inquiry. Science is a way to find answers to questions about the world around us. Scientists are very much like detectives, using evidence to solve complex puzzles. Scientists find evidence by conducting experiments and making observations. The process used by scientists to research a question is called scientific inquiry. Trying to find the answers to a question is also called the scientific method. A scientific inquiry begins with a question about the world around us and how it works. After a question has been identified, the next step is to collect all of the possible information that relates to that investigation by doing background research, making observations, and conducting experiments. Background research looks at the findings of past scientists to predict what will happen in an experiment. This prediction is called a hypothesis. Scientists test their hypotheses by making observations and comparing them to their predictions. Observations require using your senses the way something looks, smells, feels, or sounds to describe an event. Some observations are quantitative and made in the form of measurements. Some are qualitative and based on the qualities of something. The findings of the scientific inquiry are referred to as conclusions. Hypothesis, a prediction or proposed explanation that can be tested. Observation. Using all of your senses and scientific instruments to describe a thing or event. Conclusion, the findings of your scientific investigation. Scientific inquiry. The strategy used for scientific investigations. Quantitative information or data based on countable measurements of something. Qualitative information based on the qualities of something. A measurement has both a number and a unit: 3 feet, 45 minutes, 25 degrees Celsius, 1 liter, and 115 pounds. A model is a representation of something that's too small, too big, or too expensive to observe in real life. Since models simplify things to make observing and thinking about them easier, they are very useful tools for scientists. These are a few types of models. Physical models, like a globe or a diorama. Computer models, like a simulation of changing weather patterns or 3D simulations of people or places. Mathematical models, like the equation of a line or a business using past costs to predict future costs. An express error ment ISN, TA failure if it doesn't work out as predicted. No win GWHAT is val z is an importer NT party of figu ring out YT is true. UPS, Luke out bellow W. Plus equals. X. Underscore after making many observations, scientists develop ideas to explain how and why things happen. Scientific ideas start as predictions, and evidence may or may not support them. After a hypothesis has been confirmed through many tests and experiments, scientists can develop a theory. A theory is a proposed explanation that has been extensively tested and is based on many observations. A scientific LAW, like a theory, is based on many observations. A law is a rule that describes how something in nature behaves, but not necessarily why it behaves that way. For example, Sir Isaac Newton observed that objects naturally fall to the ground. To describe this pattern, he came up with the law of universal gravitation. This law predicts the motion of objects under the force of gravity but doesn't explain why objects move that way. Scientific ideas, theories, and laws. Law describes what happens under certain conditions. Theory, an explanation of why something happens, based on years of testing and observation. STRUE. Check your knowledge. 1. What are the three main branches of science, and what does each study? 2. What are the basic steps of scientific inquiry? 3. What is a hypothesis? 4. If your observations do not support your hypothesis, what should you do? 5. How is evidence used in scientific investigations? 6. Compare and contrast a theory and a law. 7. What are models, and why are they used in science? 8. Give an example of a physical model, a computer model, and a mathematical model. Check your answers. 1. Life science or biology is the study of living things, earth science is the study of the earth and space, and physical science is the study of matter and energy. 2. Ask a question, do background research, make a hypothesis, test your hypothesis, analyze results, draw a conclusion, and share results. Or, if your hypothesis is proven false, make a new hypothesis and start again. 3. It's an educated prediction that can be tested. 4. Make a new hypothesis based on your observations and begin the process over again. 5. Evidence, observations and data can either support or oppose a hypothesis. 6. A theory explains why something happens. A law identifies what happens in nature but doesn't necessarily explain why it happens. 7. A model is a representation of something. Models are used in science to help us think about things that are difficult to observe in real life. 8. Physical models, maps, globes, and dioramas. Computer models, 3D simulations of people or places and simulations of moving weather fronts. Mathematical models, equations, such as the equation of a line, and mathematical simulations.